Hey YouTube, Sarko here, and the most extreme objects in the universe are of course black holes, but there's a step just above this known as neutron stars, which you may have heard of. But what are they and how do they form and how are they different to black holes? Well, it all has to do with mass and fusion. So fusion of course is where, for example, what's going on in the sun right now, even though it's nighttime so of course we can't see it, the sun is smashing hydrogen atoms together, and when they smash together they form helium, and this is called nuclear fusion because it releases a huge amount of resultant energy, enough to keep us warm here 8 light minutes away. So it's very powerful of course, but it can't go on forever because eventually it's starved up all its hydrogen into helium, but it can still combine this helium into denser elements, but eventually it reaches iron. And the thing is, you can't actually do fusion on iron because it's too large. You can't really combine it with anything else to release more energy than you started with from the reaction. So the star is experiencing gravitational pull trying to crush it, and this fusion, when it stops after the star has reached iron, it can't fight back against its gravity, so the star starts to get crushed inwards by its own gravitational pull. And if the star is around 1.3 to 2 times the mass of our sun, then it will form a neutron star. But if it's above that, it will form a black hole, because black holes are crushed by more force because the star is of course larger, has more mass, so there's more force pushing it together. And for it to become a black hole, it has to get below this special range called the Schwarzschild radius, which is basically if you crush any object below this amount, which is proportional to the size of the object. It's not like a fixed amount for every object. It will become a black hole. For example, for the Earth, to make it a black hole, you'd have to crush it to the size of a peanut. But it's a bit larger, neutron stars are, than that, and they're a bit less dense. Like a neutron star with the mass of the sun would be 20 kilometers wide, a black hole around 5 kilometers wide with the mass of the sun. And neutron stars are still under so much pressure, it's very hard to even imagine. The protons and the electrons in them get crushed into neutrons under their own pressure deeper inside the star, and that's where they get the name from. And this actually makes the strongest material in the universe, called nuclear pasta, which is literally the scientific name given to the material inside of neutron stars, because I guess it kind of looks like pasta if you ever seen a picture of it. Well, not an actual picture, but what it's theorized to look like. And of course, it's the strongest thing in the universe. Even though if you were to open a neutron star to get it, it would all expand out instantly without the huge pressure holding it in place. But there's another interesting thing about neutron stars, and that is pulsars. Sometimes neutron stars release huge, powerful jets out, and they spin around, and sometimes these jets happen to line up with Earth. And so there are several pulsars that are neutron stars that are spewing out huge amounts of light, sometimes the quickest one 700 times a second, that is coming towards Earth. And it looks very interesting, and also confused the US when they first discovered it.